Welcome dear students to this session. Today we are going to discuss from class 9 mathematics book on chapter 8 Quadrilaterals part 5. Before going to discuss today's lesson, let's recap what we have learned previously. You see, we discussed that a diagonal of a parallelogram divides it into two congruent triangles. In a parallelogram, opposite sides are equal. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. In a parallelogram, opposite angles are equal, and its converse is, if in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. We also discussed that the diagonals of a parallelogram bisect each other, and its converse is, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Today we are going to discuss some other property of a parallelogram. What is that? It is like this. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. So let's understand it, that we know that in a parallelogram opposite sides are parallel and equal. Here the condition is that if one pair satisfies this condition, then also the quadrilateral is a parallelogram. So have a figure. The figure is like this. ABCD is a quadrilateral in which AB is parallel to CD and AB is equal to CD. Then what to prove? We have to prove that ABCD is a parallelogram. As we know, to prove it a parallelogram, we need to prove AD is parallel to BC. For that, we need a transversal, so we have to construct something. What is the construction here? Draw diagonal AC. Now after drawing this diagonal, how to prove it? Let's see. AB is parallel to CD and AC is the transversal. So we can have the alternate interior angles, that angle BAC is equal to angle ACD. Now in these two triangles ADC and ABC, are they congruent? If they are congruent, what are the conditions? See, AB is equal to CD. It is given. And AC and CA are this is the common side to both the triangles. And also we just proved that angle BAC is equal to angle ACD. So these two triangles are congruent by side angle side property. Here the side angle and side. So side angle side congruency, these two triangles are congruent. As these two triangles are congruent, we can say the DAC angle and BCA angle. These two are equal because they are corresponding parts of a congruent triangle. Now you see, if these two are equal, these two angles are equal, what is the condition of these two angles? You see, if we consider AC as the transversal and AD and BC are the lines, then we have DAC and BCA to be alternate interior angles. And here we proved that DAC is equal to BCA. So if the alternate interior angles are equal, then these two lines AD and BC are parallel. So we proved that AD is parallel to BC. Now in quadrilateral ABCD, we have AB is parallel to CD as it is given, and now we prove that AD is parallel to BC. As the opposite sides of a quadrilateral are parallel, so this quadrilateral is a parallelogram. So we can say that ABCD is a parallelogram. By using this property, we can solve many problems. Let's have a look at the question. ABCD is a parallelogram in which P is midpoint of AB and Q is midpoint of CD. If AQ and DP intersect each other at S, similarly PC and BQ intersect each other at R, then we have to show that APCQ is a parallelogram and DPBQ is a parallelogram, and again PSQR is another parallelogram. So let's see. As ABCD is a parallelogram, AB is parallel to CD and AB is parallel to CD and AD is parallel to BC. Now the midpoint of DC is Q and midpoint of AB is P, and DP and BQ are joined, and so they intersect like this. Let me write only proof. Now you see ABCD is a parallelogram. This implies AB is parallel to CD and AB is equal to CD. Now you see, if AB is equal to CD, then half of AB is equal to half of CD. Now you see, what is half of AB? Half of AB can be AP or BP. So in one place we can say AP is equal to half of CD can be written as QC, and also half of AB also can be written as BP, and half of CD can also be written as DQ. Now in quadrilateral, APCQ, in quadrilateral APCQ, we know that AP is parallel to CQ as AB is parallel to CD. So we can write AP is parallel to CQ, and it is proved that AP is equal to QC. So I can write AP is equal to CQ. So as the opposite sides of the quadrilateral are parallel and equal, so that quadrilateral is a parallelogram. So we can write that APCQ is a parallelogram. Again, in other quadrilateral, that is BPDQ, in quadrilateral BPDQ, BP is parallel to DQ as part of AB and CD. As AB and CD are parallel, so BP is parallel to DQ, and we proved that BP is equal to DQ. Again, as opposite side, one pair of opposite side are equal and parallel, so we can say BP DQ is a parallelogram. as we proved that APCQ is parallelogram, from this we can say that here we can say that DP is parallel to BQ. Similarly, as BPDQ is a parallelogram, we can write from that DP is parallel to BQ. In this case, as APCQ is a parallelogram, we can say AQ is parallel to PC and DP is parallel to BQ. Now consider the quadrilateral PSQR. So in quadrilateral PSQR, as PD is parallel to BQ, we have PS is parallel to QR, and as AQ is parallel to PC, we can say SQ is parallel to PR. You see, in quadrilateral PSQR, opposite sides are parallel, so PSQR is a parallelogram. So here we proved by using that the opposite sides of a parallelogram are equal and parallel. The opposite sides of a quadrilateral are equal and parallel, then it is a parallelogram. Using this statement, we can prove this. Now, let's have another question. The question is like this. Here in the figure, in triangle ABC and DEF, we have AB is equal to DE and AB is parallel to DE. Again, BC is equal to EF and BC is parallel to EF. Okay? Then vertices A, D, C, F and BE are joined. We have to prove that ABED is a parallelogram, BEFC is a parallelogram, and ACFD is a parallelogram. From this, we can also prove that AC is equal to DF as the opposite sides of a parallelogram. Then after using this, we can also prove in triangle ABC and DEF, we have AB is equal to DE, AB is parallel to DE. Again, BC is equal to EF and BC is parallel to EF. The vertices A, D, C, F and BE are joined. Then we have some quadrilaterals here like ABED. ABED is a parallelogram, BEFC is a parallelogram, ACFD is a parallelogram. We have to prove this. Then from this we can show that AC equal to DF, and from this we can also prove that triangle ABC and triangle DEF are congruent. Let's see how to prove it. In triangle ABC and DEF, we have given that AB is parallel to DE and AB is equal to DE. Again, We have also BC is parallel to EF and BC is equal to EF. Now if we join AD and CF and BE. Now see, ABD and AB equal to DE. This constitute which quadrilateral? This constitute ABED quadrilateral. So in ABED quadrilateral, AB is parallel to DE and AB is equal to DE. So as the opposite sides of a quadrilateral are equal and parallel, so we can say that ABED is a parallelogram. This is first part to prove. Now you see, if ABED is a parallelogram, which are the other opposite sides? Other opposite sides are AD and BE. So we can say AD is equal to BE and AD is parallel to BE. Now again consider this one, BC is parallel to EF and BC equal to EF. From this, BC and EF constitute BCFE quadrilateral. So in BCFE quadrilateral, BC is parallel to EF and BC is equal to EF. Again, as the opposite sides of a quadrilateral are parallel and equal, so we can say that BCFE is a parallelogram. As it is a parallelogram, its opposite, other pair of opposite side also parallel and equal. This implies BE is parallel to CF and BE is equal to CF. Now you see, one condition is here and another condition is here. The second part of the proof is proved here, that BCFE is a parallelogram. Now from these two conditions, we can say that AD is parallel to BE and BE is parallel to CF. Hence, we can name it, say, condition A and name it as condition B. From condition A and B, we conclude that, see, in case of A, AD is equal to B and here it is B equal to CF, we can also write AD is equal to CF, and now see the parallelity, AD is parallel to BE and B is parallel to CF, so AD is parallel to CF. Now see, AD is equal to CF and AD is parallel to CF. So ADCF constitute which quadrilateral? ADFC. We can say ADFC quadrilateral. So in ADFC, so we can directly write that ADFC quadrilateral is a parallelogram. as ADFC is a parallelogram, we can say AC is equal to DF. So, from this we can conclude that AC is equal to DF. As ACFD is a parallelogram, so AC is equal to DF. Now, this is the third part of the proof. Fourth part of the proof. The third part of the proof is this one. Now, you see, in triangle ABC and triangle DEF, what are equal? AB is given to be equal to DE and BC is given to be equal to EF. These two are given, and now we prove that AC is equal to DF. So, by which congruency these two triangles are congruent? So, triangle ABC and triangle DEF are congruent by side congruency. So, from this we proved all the 6 parts of this proof. Now, let us see another question. Diagonal AC of a parallelogram ABCD bisect A, show that it bisects C also, and ABCD is a rhombus. Now, see, given ABCD is a quadrilateral and the diagonal AC bisect angle A, means angle BAC is equal to angle DAC. Then we have to prove that this diagonal bisects angle BCD. That means we have to prove angle ACD is equal to angle BCA. So, here it is given in quadrilateral ABCD. In parallelogram ABCD is given to a parallelogram. In parallelogram ABCD, AC diagonal bisects angle A. To prove AC bisects angle C. Now, how to prove this? See, it is given that AC is bisector of BAD. So, we can write as AC bisects angle A. This implies angle BAC is equal to angle DAC. Now, see, AB is parallel to CD and AC is equal to is transversal. This implies angle ABC, this implies angle BAC is equal to angle ACD. Again, AD parallel to BC, AD parallel to BC and AC is the transversal. AC is transversal. Then angle BCA is equal to CAD. Angle BCA is equal to angle CAD. Now question is like this. The equations are like this. BAC equal to DAC, BAC equal to ACD and BCA equal to CAD. Now you see, as BAC equal to DAC, BAC equal to ACD and DAC or CAD equal to BAC, so BCA is equal to CAD. From these conditions, from 1, 2 and 3, we conclude that angle ACD is equal to angle BCA. So as angle BCA is equal to angle ACD, this means AC bisects BCD. Now let's prove it to be rhombus. As it is a parallelogram, if we prove that any two adjacent sides are equal, then we can prove that this is a rhombus. Now from this we can say, from any of these two we can take BAC equal to DAC and BAC equal to ACD. So from equation 1 and 2 we conclude that angle DAC is equal to angle ACD, and DAC ACD are in which triangle? They are in the triangle ADC. So we can write, so in triangle ADC, as two angles are equal, their opposite sides will also be equal. So we can write the opposite side of DAC is DC and the opposite side of ACD is AD. That means CD equal to AD. As we know, this is a parallelogram. As a parallelogram, we have AD is equal to BC and AB is equal to CD. Now see, AD equal to BC, AB equal to CD and CD equal to AD. From these three conditions we can say, thus AB equal to CD equal to AB equal to BC. We can simply rearrange it. AB equal to BC, BC equal to CD and CD equal to DA. This implies ABCD is a rhombus. Dear students, today we discussed about another property of parallelogram, that if of one pair of opposite sides are equal and parallel, then that quadrilateral is a parallelogram. And using this we solved some problems. Dear students, I hope you understand it. Thank you.